I take paper number 2. Right. Question number 1. Yeah, we are given there the roots of the quadratic equation. Right, it's part A. X squared plus ax plus b equals 0. We are given the root of this quadratic equation as alpha and beta, right? Okay, obtain the quadratic equation 1 upon alpha squared and 1 upon beta squared as roots. Then we will first find sum of the roots and product of the roots. Sum of the roots is minus a, product of the roots is b. Now the roots given as 1 upon alpha squared and 1 upon beta squared. So then with this 1 upon alpha squared and 1 upon beta squared as the roots, the quadratic equation we can write the equation with the roots. One upon alpha squared and 1 upon beta squared is, all right, people, x squared minus sum of the roots times 6 plus product of the roots. 1 upon alpha squared into 1 upon beta squared equals 0. Okay. Here you can take the product of these two as a common denominator. So this beta squared come in here, alpha squared come in here. That is nothing but beta squared plus alpha squared. It is really alpha squared plus beta squared. This product alpha squared beta squared is really alpha beta perfect squared into x. Here 1 upon alpha beta perfect squared equals 0. Now here this alpha squared plus beta squared, you can write, people, how alpha plus beta perfect squared minus 2 alpha beta, no? Right. Okay. Now x squared minus alpha squared plus beta squared I can write as alpha plus beta perfect squared minus 2 alpha beta divided by alpha beta perfect squared times x plus 1 upon alpha beta perfect squared is equal to 0, right? Now what we do to get the required quadratic equation, substitute for this alpha plus beta and alpha beta and this alpha beta, right? Alpha plus beta is minus a. Then here minus a perfect squared is plus a squared minus 2 times alpha beta is b divided by alpha beta perfect squared is b squared x plus 1 upon b squared is equal to 0. So now we can multiply this both sides by b squared. Then here we get b squared x squared minus a squared minus 2b times x plus 1 is equal to 0. Right? This way we get the quadratic equation whose roots are 1 over alpha squared and 1 over beta squared, right? Yeah. Now this equation has the roots 1 upon alpha squared is 1 root. The other root is 1 upon beta squared, right? Now asking, hence deduce the quadratic equation whose roots are 2 beta squared plus 5 upon alpha squared and 2 alpha squared plus 5 upon beta squared. Asking to deduce, yeah. Now the two roots given 2 beta squared plus 5 upon alpha squared, 2 alpha squared plus 5 upon beta squared. You can very clearly see these two roots are symmetric. What is meant by people? The symmetric. There are two different letters, no, alpha, beta. For the case of alpha, when you put beta, and for the case of beta, when you put alpha, selecting one root out of these two. Say we take this beta we replace by alpha. This place therefore 2 alpha squared. This alpha we replace by what? Beta. This is beta squared. Then we get 2 alpha squared plus 5 upon beta squared. This is coming. That is why we say these two roots are symmetric. When the two roots are symmetric, people, under this method, you know, we can take any root out of this 2 as y. Then I take this as y. Let y 2 beta squared plus 5 upon alpha squared. Now you can write like this. Take the common limit here. Alpha squared. Then this beta squared should be multiplied by alpha squared 2 times alpha squared beta squared plus 5. There this alpha squared beta squared mean alpha beta perfect squared, no, but alpha beta is b. 2b squared plus 5 divided by alpha squared. Now what I do is this part we take to left hand side denominator, y upon 2b squared plus 5 come in is equal to 1 upon alpha squared. We subject 1 upon alpha squared. This is okay, right? But you know this 1 upon alpha squared. This means it is a root of this equation. Understand? 1 upon alpha squared here is a root of this equation. Therefore, this 1 upon alpha squared, that means this figure, should satisfy this equation. It means when I substitute for this every x here and here, this y upon 2b squared plus 5, the left hand side resulting expression should be equal to this 0. Understood? Okay. Yeah. Then you can write this way. Since 1 upon alpha squared is a root of above equation, substitute for this x. That. Then u squared. For this x, I have substitute what? This part. Y upon 2b squared plus 5 for x squared minus b squared minus 2b x is this y over this. So we squared plus 1. Plus 1 equals 0. Okay, this way we get. Now we need to obtain our y is this, no? Right? Y was really this root. This is one of the given two roots. So then we need to take the quadratic equation involving y. Then simplify this. I multiply this both sides by 2b squared plus 5 perfect squared. By this factor, when you multiply this term, here we have 2b squared plus 5 perfect squared. that and this will cancel off, giving y squared, v squared. V squared, y squared. And by this perfect square, when I write here to multiply this, 1 power of that we cancel with this now. Then we get 2b squared plus 5 within first bracket here. Other one is this. Okay. And y. And this one, when you multiply by this, we get 2b squared plus 5x squared equals 0. Right? So this is our required what equation. Huh? This is our required equation. This is the required equation. Right? This is how we do that part. Huh? Right now. Yeah, we'll take the part we need. Part we need. Partial fraction part. Find lambda, mu, and nu such that 1 upon 1 minus x, 1 minus bx, 1 minus cx. Equals lambda upon 1 minus ax, mu upon 1 minus bx, mu upon 1 minus bx. Right. Okay. Right. Now we'll multiply both sides by the left hand side denominator 1 minus ax, 1 minus bx, 1 minus bx. Okay. Then what happens is this thing will cancel with this, we get 1 here. When I write this thing before this lambda, this 1 minus x will cancel with this lambda times this product we get, no? Right. Again, when you multiply this before this 1 minus bx will cancel with this. The mu should be multiplied by 1 minus ax, 1 minus bx. Mu. Before this mu, when you write this 1 minus bx will cancel with this. By this two we have to multiply. 1 minus x, 1 minus bx. This is we get, huh? Right. Now we substitute values here. First we put x equals 1 upon b. We substitute in both sides. When you put x equals 1 upon b, what happens? It says bx product equals 1. That means this is 1. Then 1 minus 1, this bracket is 0. Then 1 minus bx bracket will be 0. If this bracket is 0, the whole thing is 0. This bracket 0, this thing is 0. Suppose this x here and here, this 1 upon b. 1 equals mu times 1 minus b times x. 1 upon b. This way we get 1 minus c times x, 1 upon b. That is we get. Huh? Then we'll take here common denominator as b minus c upon b minus c upon b. Okay, no? Right now, b and b squared, bring that here. b squared into 1 b squared divided by this product. Then we get mu, right? Therefore, mu is equal to b squared upon b minus a, b minus c. This way we can find mu, right? Secondly, we'll put x equals 1 upon a. X equals 1 upon a when you put what happens? X equals 1 upon a means when you bring this here, ax equals 1. That means this ax equal to 1. Then 1 minus 1, this bracket 0. X equals 1 upon a mean therefore people, this 1 minus ax bracket becomes 0. This bracket 0, entire product 0, this bracket 0, entire product 0. Here, this we have substitute there. Lambda 1 minus b times 1 upon a, c times 1 upon a. Right. Now, we take here common limit as a, then this will be a minus b, here a minus c, then here we have a, here we have a, that we can bring here, a squared. Now here we had a minus b, here we have a minus c, that a minus b and a minus c we can bring left hand side denominator like this. This is our lambda. Therefore, lambda equals a squared over a minus b, a minus c. Right. Next one, put x equals 1 upon c. Put x equals 1 upon c. When you put x equals 1 upon c, x equals 1 upon c means really what? Taking the c here, cx equals 1. Then 1 minus cx bracket, this bracket will be 0. Substitute here, left hand side 1. Mu 1 minus a, x is 1 over c, right? 1 minus b over c. Then here take common limit as c, you also c and c, c square, mu, this is c minus a, c minus b. Then subject mu, bring the product here, like this. All right. Now we found people this lambda, mu, and nu. Lambda, mu, and nu we found. Right. Okay, now we can substitute for this lambda, mu, nu. Okay. We substitute here the found values of lambda, mu, nu. Lambda, mu, nu, we substitute here. Then let's see what we get. Then we can write how? 1 over 1 minus ax into 1 minus bx into 1 minus cx. Equals lambda. this a square divided by this into this. Square divided by a minus b, a minus c. I just substitute for lambda. Now the 1 minus x there we have. Plus mu b squared over b minus a, b minus c. I substitute for mu 1 minus dx. Plus. Next one is nu. For this, it is c squared over c minus a, c minus b, right? What? 1 minus dx. Right. We found lambda mu nu. Yeah, hence deduce. That means using this result only we need to do the rest part. Use this result. Right? Right now? Now, here this equality mean really, this left hand side and right hand side equal mean, there we have an identity. This left hand side and the right hand side equal for all x values. Then what I put is people, I put x equals 0 on both sides. Any value for x we can put because this equality is an identity. Left and right are equal for any value of x. Yeah, put x equals 0. Then what happens? X equals 0 means this 0, this bracket 1, this 0, this bracket 1, this 0, this bracket 1. 1, 1, 1, 1. 1 upon 1 is 1. Therefore, left hand side is 1. Okay. Here, put 0. We get this divided by this. Here, x0. This is 1. B squared over b minus c, b minus c. Here, x equals 0. C squared over c minus c, c minus c. Right? What's the answer? Correct, no? A squared over this is correct. A squared over this is correct. This is correct. 1 equals this means this equals 1. The answer coming by that. Okay. All right. That part is okay. Question number 2 now. Take. Number 2. Sketch the graph of y equals x plus 2 times mod x minus 1. No? Right. You can define mod x minus 1. No? It changes that x equals 1. No? Mod x minus 1 on the right of 1, this is minus 1, x of 1, then multiply minus 9, minus 6 plus 1, no? Minus 6 plus 1. Right now, on the right of 1, number 1, when x greater than or equal to 1, I'm going to find what is this. Y plus x plus 2 times mod x minus 1. X plus 2 times mod x minus 1 on the right of 1 is x minus 1. Then here we get y equals here 2x and next 3x minus 2. Right? Right. Next one, when x less than 1. Right. This one, no? X plus 2 times x less than 1 mod x minus 1 is minus x plus 1. Let's see. Here minus 2x plus x minus x plus 2. Right. Now, we know one point. When we find one point, definitely we have to put x equals 2. Right? Right. Here we have to put x equals 1. Put x equals 1. 3 minus 3 is 1. 1 point is 1, 1. Here x equals 1. Same point coming. No need to check even. The other point we'll find when we do it. Right. First, shall we draw this one now? Right. 1 point is 1, 1. Here. 1 point is this. The other graph to be drawn is this now, people. What's that? Y equals 2x plus 1. It doesn't contain modulus. Right. This graph, when x greater than or equal to 1, 1 point is 1, 1, other point having intercept minus 2. Is 1, 1. Minus 2 here. Much nearly. Then the graph passes through this point and this point. But when we join them, right, 1, 2. Right, now we join these 2 points. You see, and produce this thing now. But we need this graph only in the interval greater than 1. No, so therefore, this portion we draw by using dotted line like this. Then the equation of this branch is y equals 3x minus 2. For this one, again the same point, intercept is plus 2. Plus 2 is here 1, here 1, this is 2. This is this 2 we have joined. This point is 2. The line should be produced to this end. This is 2, right? This equation is y equals minus 6 plus 2. Okay. Now this line y equals 2x plus 1. Intercept is 1. That means this line passes through point this. Another 1 point we need to find that point. We'll put y0. Put y0. Put y0. X is minus half. Other point minus half 0. Minus half is here somewhere, people. Then you have to join these 2 points and produce both ends. You see it cuts. Now this equation y equals 2x plus 1. Yeah, you can very quickly understand here the gradient is 3, right? Right. Now here gradient is 2. This line gradient is 3. Gradient 3 means with the positive x-axis more angle it makes. Gradient 2 means lesser angle it makes. So therefore, when we draw this inclination lesser, then this definitely this line and this line must meet there. Okay. Now what is asking? Yeah. Now asking this say yeah. Hence all the inequality. Hence all the inequality. What is that? Minus 6 plus 2 times x minus 1 greater than 1. This inequality asking. Take the answer here. Okay. Yeah. Now I can write it like this. We'll bring this minus 6 right hand side. 1 plus x coming. Now we'll add another x to both sides. We get x plus 2 times mod x minus 1 greater than 1 plus 2x. This is what we get. What is this? Is the black graph we drew. This is blue graph we drew. What is asking? The range of x, black graph is greater means black graph should be above. Black graph should be above the blue one. You can see on the left of this point, the black graph is above the blue. On the right to this point. Again, the black graph is above the blue. Then we have to find here A, suppose here B. At A and B, the x coordinates we have to find. Then the answer coming on the left of A and right of B. Right? Okay. We take this as star. Now, no, point A will find. How to find point A? Solve this line and this line. Y minus x plus 2 and y 2x plus 1. Equate the right hand side. 2x plus 1 is equal to minus x plus 2. Bring to this side 3x. This is right hand side 1. X is 1/3. This 1/3. Point B. How take that? Equate this 3x minus 2 with this 2x plus 1 because point B is the intersection of that two. Right? 3x minus 2 equals 2x plus 1. Bring this 2x to the side, x is right hand side, x is 3. Yeah? Then the last answer you can write. You see how star occurs here. This is star now. Star occurs on the left of A, right of B. No, then you can write. Therefore, star becomes true in x less than 1/3 or x greater than 3. Okay. Therefore, final answer you must write the given inequality becomes true. Write again this interval. That's how we take the answer. Part B, question number 2, part B. Question number 2, part B. Given that, state and prove Riemann theorem. Right, write Riemann theorem. Write down Riemann theorem. When a polynomial function, write down Riemann theorem. When a polynomial function fx is divided by x minus a, simple layer. When the polynomial function fx is divided by x minus a, the remainder is fa. The remainder is fa. So let's see how to prove. State and prove, no? How to prove this? We assume like this. When the fx is divided by x minus a. This is the first degree divisor, no? Then the remainder should be 0 degree remainder. 0 degree polynomial function means a constant. Say r. Huh? And here I assume the quotient as hx. Right? Then by using the algorithm of division, we can write fx is equal to this multiplied by this plus r. Then write down like this. Write down let hx and r, capital R. Let hx and capital R be the quotient and remainder. The quotient and remainder now by algorithm of division. Now by algorithm of division, fx equals x minus a into hx plus r. Okay. Now put, and now here we have an identity. Left and right are equal for any value of x. Now put x equals a. We get f is equal to a minus a is 0 into h plus r. R equals f. This is the proof of remainder theorem. Right. Here comes the question. The polynomial 2x5 minus 4x4 plus 3x squared plus px plus q is exactly divisible by x minus 1. Exactly divisible by x minus 1 means people no remainder. Remainder is 0. And on dividing by x minus 2 leaves the remainder 7. Right. I will this now. The function is this 2x5 minus 4x4 plus 3x squared px plus q. When this is divided, when this is exactly divisible by x minus 1, exactly divisible by x minus 1 means this x minus 1 first we equate to 0 and find x value. It is 1. When that polynomial function is exactly divisible by x minus 1 means when it is divided by x minus 1, no remainder. That means according to remainder theorem, when you put this 1 for every x in the polynomial function, the simplified answer should be 0. Right? Then first equation we can write 4 into 1 to the power 5 minus 4 into 1 to the power 4 plus 3 into 1 squared 3 into 1 plus q is equal to 0. Then here p plus q we get is equal to here 2, here 3, 5. 5 minus 4 is 1. Take 1 to right hand side minus 1. Number 1. Secondly, on dividing by x minus 2, now secondly it is divided by x minus 2. Then how to find the x value to be substituted in that function? First equate is 0 and find x. X is 2. On dividing x minus 2, remainder is 7. It means when I substitute for every x in the function, this expression should be equal to 7. Put x equals 2. 2 into 2 to the power 5 minus 4 into 2 to the power 4, 3 into 2 squared, 3 into 2 plus q. This should be equal to 7. Here 32 into 64. Here 2 to the power 4 equals 16 into 4, also 64. Correct, no? 2 to the power 4 is 16 into 4, 64. Here 12. Here 2p plus q equals 7. This 2 can cancel down. 2p plus q brings right hand side. 7 minus 12 is minus 5. This is number 2. Now take 2 minus 1. 2p minus p, it's p. Minus 5 minus 1 means minus 4. P is minus 4. Put p minus 4 and take right hand side. That will be plus 4 minus 1 is 3. Q is 3. P and Q are okay now. Right now, these values of P and Q, now we can write this polynomial function substituting for P and Q, these values, P minus 4, Q 3. Then P minus 4, when I put P, I will get minus 4x. Q is 3. Right? This is the polynomial function for these values of P and Q. Right. Now asking, hence find the remainder when the given polynomial is divided by x squared plus x minus 2. Now this polynomial function is divided by x squared plus x minus 2. Right. I think up to here you could understand, no? Then this is what I assume. When this is divided by the divisor given as x squared plus x minus 2. Here, the polynomial function is of degree 5. Here, degree 5. Divisor is degree 2. Then this should be degree 3. The remainder should be, people, we know the remainder should be having the degree always less than the degree of divisor. Divisor is second degree, no? Then lesser degree means first degree or 0 degree. Since we don't know exact degree, always we select the degree as maximum possible degree. Right? Here 2, therefore here degree should be 1 or 0, therefore this should be degree 1. Then we assume here first degree polynomial as our remainder ax plus b. This one we are not asked to find, therefore I will take that as gx. The function. Right now, here we have this polynomial function. Here we have that given divisor this. I assume the quotient as gx, remainder as x plus b. Now we can write by using the algorithm of division, this polynomial function is equal to this divisor into gx plus x plus b. Understood? Right? I will write by the algorithm of division that polynomial function 2x5 minus 4x4 plus 3x squared minus 4x plus 3 is equal to x squared plus x minus 2 into gx. Plus a plus b. Now we need to find a and b. Then only we get the remainder, right? Now you can see this x squared plus x minus 2 can be factorized. What are the factors? It is x plus 2, x minus 1. Okay. Correct, no? Minus 2, 2x minus 1 plus 6, x squared common. Yeah. Now we can put x equals 1. Put x equals 1. Right. We know when you put x equals 1, this function should be 0, no? We obtain this one, put in 4x, 1, no? This left hand side 0. The same thing only here we have. Therefore, that is 0. This one, when we put x equals 1, this bracket 0 means this entire product is to 0. When you put x equals 1, here we get a plus b. In one equation, first equation, we get a plus b equals 0, number 1. Secondly, put x equals minus 2, because at x equals minus 2 also, this bracket 0, the entire product will be 0. Put minus 2. 2 minus 2 to the power 5, 4 minus 2 to the power 4, 3 minus 2 squared, minus 4 minus 2, plus 3 is equal to, this is 0 to product 0, here minus 2a plus b. Equal here what do you get? Minus 2 to the power 5 means minus 32 minus 64. Here plus 16 into minus 4 minus 64. Here plus 4 into 3, it's 12. Here plus 8 plus 3 minus 2a plus b. Right. Now, here we get 23. Here we get minus 128. Minus 128 plus 23 means minus 105. Then we get minus 2a plus b equals minus 105. This is number 2. Now, this equation and this equation, they are two simultaneous equations. By solving them, you can find a and b. Take the answers of a and b. That two answers of a and b, we have to put where? Here and here. Thereby, you can write the remainder. Understood? So therefore, I am not going to show you how to solve this equation number 1 and number 2 for the simple a and b. I think you can do that. Huh? Put that a b values in number, no, that over ax plus b there. Right? And then we get the record remainder. Right? That's how we take the answer. Right? We'll come to part C. Part C, logarithm part. Solve 2 times log a to the base 6 plus log a to the base x plus 3 log a to the base a squared x equals 0. Solve means find x. Solve means find x, right? Yeah. Now, this is how we solve that. This log term, at the moment it is here, its denominator is 1. No? This log term I can take to denominator from this numerator. Then you have learned one rule. What is the rule? When I take this to denominator, this number and this number exchange their places. The same thing I do for this term and this term. Okay. There I take only the log term, not this coefficient. Coefficient be there. Here also this 3 should be there. We have to bring this to denominator. All right. So then what we get is 2 over log x to the base a plus this one log a x to the base a plus 3 times 1 over log a squared x to the base a equals 0. Right. Now, this one, you can write here we have a product. When you have a product, that one you can write as what? As a sum, log a plus log a. This way you can write that as a sum. Here, 3 into 1 means 3. This also a squared and x are product, no? Then we can write that as a sum. like this. Is equal to 0. Hmm? This value log A is 1. Yeah. You can bring this to before. You know, we have such rule. You take this to before. Again, we have log A. It is 1. Then 2 into 1 means here 2. Now what I do is we have log XA. This one we take as T. Let equals log x to the base A. This way we take. Then we get there T, 2 over T. 2 over T plus 1 over, this is 1 plus T. Plus this is 3 over, we told that 2 can be put before, no? 2 into 1 means 2 plus this is T equals 0, right? Now what we do, people, we multiply this both sides by T into 1 plus T into T plus 2. By this product of this 3, we multiply. Then we get this 2 should be multiplied by, we multiply that by this product, this thing we must write here. This T and this will cancel off. 1 plus T, T plus 2 come in there. Here, this 1 plus T factor will cancel. T times T plus 2 come in. Here, T and 1 plus T equals 0. Now, simplify this. You get quadratic equation in T. What do you get here? This T and this T, T square into 2, 2T square. Here we get T square, then 3T square. Here we get another 3T square. Then altogether 6T square. Right. Now T terms. What are T terms? This and this 2T. This and this T. Then 3T. And with this 2, when we multiply 6T. Here 2T, 8T. Here 3T, 11T. Correct, no? Here 6T, 2T, 8T, 3T, 11T. Now the constants. What are the constants here we get? 1 into 2, 2. 2 into 4. Here 1 get, here we 1 get. Here we get 4. Right. Then we can factorize this. Here this 6 and 4, 24, no? 24 we can write as a product. So that the algebraic sum to be 11. It is nothing but 6T plus 11T plus 4. Now you can factorize this. By these two terms, you can take 2T out, 3T plus 4. Here, 11, not 11T, yeah, 3T, yeah. 8T plus 3T, not, then only we get 11T, yeah. Then, by these two terms, we get plus 1 now. 3T plus 4 equals 0, right? Then we get 2T1, 2T plus 1, 3T plus 4 equals 0. All right. By this, you can take people two answers for T. T is minus half. T is minus 4 by 3. This way, there are two answers. Finding this T is not our final answer. We must find its unknown is X. X should be found. To find this X, we use what? This relation. We use this relation. Right now, when t equals minus half, when t equals minus half, there are two answers now. But t is what? Log xa. Put here log xa equals minus half. Then how to subject x? Remove this log, keep x in the left hand side, bring this base of log. It is simply to write e to the power minus half. E to the power minus half you can write as 1 upon e to the power plus half. But plus half power of a means root a. 1 answer for x is 1 upon root a. Second one, take minus 4 by 3. When t equals minus 4 by 3. Log x will be a minus 4 by 3. X equals a to the power minus 4 by 3. This one you can write as 1 upon e to the power 4 by 3. Okay, this is how we take the two answers. Right, question number 3. Differentiation part. Using first principle, show that the derivative of fx equals ex is ex. Right. You finished? You will certainly write down this. After this discussion, if you have time, again do this question without looking at the answers. At the moment, first understand how to take these answers. Again, you must do this one. All the papers you must do again yourself. Right. Then only these methods you can permanently store in your memory long time. That kind of memory power is very important to work out questions at an examination. Because people, memory power, the deep memory is proportional to the final result. Okay, right. So therefore, these methods of getting the answer, you have to have in your memory. For this, don't buy hard. Do the same question again and again. If you buy hard, you can focus only that kind of situations. If you keep this in your memory, that occasion, that memory you can apply for similar situations. Though the present question is highly deviating the one you have done before, still that memory you can manage how to apply that. You can understand if we have done this question again, then such memory if you keep in your mind. Okay, therefore the best thing is do the questions again in the paper, right? Okay. Right, come to number next 3. Right, use fx ex. Right. So what is the definition, people? Dy by dx, limit delta x going to 0. What? Fx plus delta x minus fx divided by delta x. This is the definition of dy by dx. You can start directly from this definition. Okay. Now I can write substituting by here x plus delta x, fx plus delta x. Here we have x, no, the same x only here we have. When we have substitute for this x plus delta x. Therefore, this place also this x should be x plus delta x. Then we get ex plus delta x minus fx. Fx means the same function here. Divided by delta x. Okay. Now we can write limit delta x 1 0 This one you can write e to power x into e to power delta x minus e to power x divided by delta x. Correct, no? Now here, when the bases are equal and when they are multiplied, the powers we can add, no? Then this one we get. Now this ex and this ex we can take out. Because this ex, delta x going 0 mean delta x going to 0 does not anyway affect what that x, you know that. Delta x means small increment in x. We add very small value to what x. That added value is delta x. That added value now going to 0 means it is to say we have not added. That means the x is still the same. That is why we say x doesn't change. Right. So then, since delta x 1 0 doesn't affect to this x, then ex won't change. That is why we could take this ex out from this bracket. Now I write limit delta x 1 0. Here now we have e delta x minus 1 divided by delta x. Right. However, you know this is 1. This is 1. See the theory, right? Then 1 into ex is divided by dx ex. So we get d upon dx ex as ex. This way we get root of ex as ex. Okay, next one. Differentiate x into e to power 2x squared with respect to ex squared. Right. I'll take this way. Let capital Y I am going to take x into e 2x squared. And I take capital X as e x squared. Right now, you know this capital Y, it's on its right hand side we have simple x. Then this capital Y I can differentiate with respect to simple x. Then this one you can take as u, this one you can take as v. U into v, you have to follow there. What is that? Keep this u as the same. When you differentiate this, we have to differentiate first e. Whatever the power, when you differentiate this e, we have learned derivative of e to the power something is the same. E to the power 2x squared. Now, we should multiply that by the derivative of this 2x squared. Derivative of this 2x squared. Derivative of 2x squared is what? 2 is kept as the same. Derivative of x squared is 2x. Plus. Now the differentiated function e to the power 2x squared should be kept as the same. Multiplied by the derivative of x. It's 1. Understood? Right. Now here we have e to the power 2x squared. Here we have e to the power 2x squared. Take it out from a bracket. Then subject d capital Y upon d simple x is equal to what, people? E to the power 2x squared. Here now what do we get? 4x and x squared. Then we get 4x squared. Here we have 1. Right. D capital Y upon dx now we have. Right. Now come to this. This x, its right hand side we have simple x. Therefore, this capital X is a function of simple x. Then we can find one derivative. D capital X upon d simple x we can find. Ex squared, when you differentiate, we get the same ex squared. Derivative of x squared is 2x. Right? Now, people, I'm going to write this. Now, I'm going to write d capital Y upon d capital X. What is this? How do we read this derivative, people? Derivative of capital Y with respect to capital X. What is capital Y? This. Therefore, this one I can read again how? Derivative of this relative to derivative of this. That means derivative of this function relative to this we get by this. But you know, this one you can write by using the chain rule. D capital Y divided by D simple x multiplied by D simple x divided by D capital X. D capital Y upon dx is this one. D simple x upon D capital X means people take reciprocal of this. Then we get the answer. D capital Y upon dx means this one. D 2x squared within bracket 4 squared plus 1. The simple x upon D capital X means the reciprocal of this, then this goes to denominator like this. D x squared into 2x. But even now here, this e to the power 2x squared you can write like this, no? E x squared to the power 2. You see, can I write that? That's possible. The reason, you know, when we simplify something like this, y cube to the power 2, these two powers we have to multiply to simplify this. Then here also, if I write ex squared to the power 2, to simplify this, this x squared should be multiplied with this 2. Then we get 2 into x squared as the power of e. Correct? No? This thing comes. Now, within the second bracket, 4x squared plus 1 divided by e x squared into 2x. Here we have ex squared. Here we have ex squared to the power 2. That means ex squared into ex squared. In 1 ex squared, we can cancel down with this. Then we get the required answer. Understood? Then we get the required answer. Right? Okay. Right. Take it part B. Part B. X squared y equals n x. Right. Ask in the differential equation you are now. Right. Second degree, second order differential equation here we have. Yeah. First we'll differentiate this. There you have to apply u into v form. X squared into dy by dx is the derivative of y with respect to x. Keep y as the same 2x. Right hand side a is a constant. Cos derivative is minus sine nx. Okay, first we have to differentiate cos minus sine nx and derivative of nx is n. Right, now differentiate this again. Here you have to again apply u v form. Keep x squared as the same. Derivative of dy by dx. When you differentiate dy by dx again with respect to x, we get second derivative. d2y over dx2, no? Plus, keep this b as the same. Derivative of x squared is 2x. Right. Now this 2xy, keep this 2 aside. xy. xy again you have to differentiate as a product. Keep this y as the same. The root of x is 1. X as the same. The root of y is dy by dx. Now come to right hand side. Minus a incoming. Sin nx derivative is what? Cos nx into n. Cos nx into n. All right. This way we get that. Right now we can write here x squared d2y upon dx2. Here 2x dy by dx. Here when you remove the bracket, we get again 2x dy by dx. Here 2x dy by dx and here 2x dy by dx means 4x dy by dx. No? Right? And now we will here this n and n squared. Right now with minus sign here. And a cos nx. And here we have 2y. You can very clearly see people here a cos nx is nothing but x squared y. This way. And the same thing coming to the next line too. Like this. Now what we do, we bring this to left hand side and take this y out. Then we get this answer, no? Right? Take that y out. Then we get x squared d2y upon dx2 plus 4x dy by dx plus. Take this to left hand side, this will be plus, and here also we have 2y. There we have y. Take that y out. Once you take y out, there we have 2 within bracket. Take this side plus n squared x squared coming there. Should be equal to 0. So this is how we take that answer. Yeah. So come to part C. So come to part C. Right. Yeah, let C be the curve given by the parametric equations x equals t and y equals 1 upon t. The tangent drawn to the curve C at A cuts the x-axis at B. So that OA equals AB, where O is the origin. It is an application of derivative, this part. Yeah, the curve is x coordinate is given by t, y coordinate is 1 upon t. Right. And now really, when I substitute t equals 6, no, the same t only here we have. So once I put here for the place of t this x, xy equals 1 we get. This is the relationship between x and y. Xy equals 1. Because this xy equals 1 graph is called as perpendicular hyperbola. Okay. This way it's shaped. It is not necessary to know the exact shape of that perpendicular hyperbola. In all pure applied syllabus, in our coordinate geometry, there were 5 lessons: straight lines, circles, parabola, ellipse, and hyperbola. Right? In addition to that, we had polar coordinate system also. In nowadays, when we were doing nails, we had polar coordinate system also. Polar coordinates mean, people, I will just explain that. You will use this in applied maths when we do applied maths in the university. Polar coordinates mean really, now when I consider this x and y axis, suppose here we have P, the point P we can denote by xy coordinates. Now, x coordinate is this length, y coordinate is this length. By using this x and y, right, we can really write the position of point P. That is why this system of this system is known as Cartesian coordinates, because using 2 coordinates x and y, we can locate the point. But people, without using this coordinate, taking the length from this O to P as R, this angle theta. Again, the point P we can denote. Then this R and theta are called as polar coordinates, people. Now, polar coordinates. Now the point P, its position, we write as R theta. That means if you know this length of the line segment OP, and if you know this angle theta, then any person at the point O can easily find the location of point P. Then, you know, when we write the equation of a straight line, the usual, for instance, this kind of equation we get, no. If you use the polar form, people, we get an equation involving R and theta. They are called as polar coordinates, polar equation of the straight line. So therefore, on the straight line, we had what? 2 forms. One, first one is the xy form, Cartesian form. Second form is this R theta form, polar form. Then 2 questions, part A, part B, we had in our exam in pure maths. For circle, also like that. And hyperbola, parabola, ellipse also, there were questions like that in our syllabus. But fortunately or unfortunately, now you don't have the chance of learning them. Right. Now, here also, we are given coordinate form, Cartesian coordinate form. This is the perpendicular hyperbola. Now, when we select a point on this perpendicular hyperbola, right? Suppose this point as a point given, the tangent drawn to the curve C at A. This point is given as A. Then any point on this perpendicular hyperbola, we can write x coordinate as t, y coordinate as 1 over t. T is a parameter. Parameter means, people, when we give a real number for this t, we get a point on this perpendicular hyperbola. When you change this t value from that real number to another real number, another point we get on the same hyperbola, but at different location on the hyperbola. So therefore, by changing this t, putting real numbers, we can bring that point along the hyperbola. Right. Now, here the tangent is constructed this way to the hyperbola like this. Right. So now this is O. Now this tangent cuts the x-axis at B. In the question asking to show this O to A length is equal to O to B length. Then what I do is this. I am first finding this equation of this AB. AB equation I am going to find. I can find this AB equation like this. First, I'll remind the way of finding this equation: y minus y naught, gradient times x minus x naught. Then we have to find the gradient. gradient can be found, people, differentiating the equation of this hyperbola C. Its equation now we can take xy equals 1 form. That is much easier to now simplify this. Xy equals 1. Y equals 1 upon x. 1 upon x means 6 power minus 1. Now dy by dx is, bring this minus 1 before, x minus 1 is minus 2. Huh? This way. Then dy by dx is equal to minus 1 upon x squared. Now dy by dx is gradient. But we need the gradient at the point A. Then the gradient function, since it contains x squared, here x means the x coordinate of the point on the curve C where we need the gradient. Gradient means m. Right. So therefore, dy by dx at A, its x coordinate should be put here. Minus 1 now, x coordinate is t. Right. Now, this is the m here. Right. Now, I'm going to use this one to find the equation of this AB. Equation of AB now. Equation of AB. What do you get? Y minus y naught 1 over t. Gradient minus 1 over t square. X minus t. This is the equation of AB. But I am not going to simplify this. I need to find only the x coordinate of the point B. But you know, y coordinate of the point B is 0. Reason? The point B lies on the x axis. Y coordinate is 0. Put y 0. We get minus 1 over t minus 1 over t squared x minus t. This t and this we can cancel down now. Minus sign also we can cancel down. Bring this t we are here. We get t equals x minus t. X is therefore 2t. People, x means this length. Therefore, what is OB? OB is 2t. Right. Correct, no? Now this OA. Right. How to find OA? Point O has a coordinate 0, 0. We know a theory to find the distance between 2 points. How to find? Difference of x coordinate perfect square plus difference of y coordinate perfect square root is the distance between 2 points. So then, using that, we can write OA. What is that? Difference of x coordinates. T minus 0, because this O is having both x, y, 0. T minus 0 perfect square. Other one is 1 minus t. Sorry, 1 upon t minus 0 perfect square. Root. Right? Right. That's the x-axis that we know. Right. Now simplify this. T we get t squared, 1 over t squared. OA. Its root. Here, t4 plus 1 upon t squared. OA. This way we get, but the answer is not coming. See what happens here. Right. Here, ask him to find what? OA equals AB, no? OA, we found there, right? Equals AB. Now we have to find AB. AB, not OB, no? Right. So then what are the coordinates of this point B? X coordinate 2t, y coordinate 0. Right. Now we'll write AB. AB we can write now. AB is equal to square root of what? Difference of x coordinate 2t minus t. It's t, no? T squared. Difference of y coordinate 1 upon t minus 0 or 0 minus 1 upon t. Whichever the order, never mind, because you square that, no? Then it is 1 upon t minus 0 perfect square. Then the answer coming, no? AB is therefore t squared plus 1 over t squared. AB is t to the power 4 plus 1 divided by t squared. Then you can take AB t4 plus 1 divided by t. Correct, no? Now we can see this figure only. Here you have. Therefore, OA equals AB. Hence, OO OA equals AB. This way we can take it.